if you look at the top of page 17, they have another equation, I guess, formula, if you want to call it that. This time is talking about volume. It's how much stuff, if you want to call it that, you can put inside of this particular figure, this three-dimensional figure. So far, we've just been talking about surface area, right? About if you wanted to paint it, or if you wanted to wrap it, or if you wanted to carpet something, or whatever, okay? Just the outside of it. Now we're talking about inside. How much stuff can you pour inside it? Like how much water could you put inside it? That's volume. Does it make sense? Or how much air can be in, or how much anything you could stick inside it. That's volume. So that's what we're going to talk about. So volume, you'll see some similarities with volume, which is kind of nice. So when you talk about volume, let's see how they say it. It says the volume of a cylinder or prism, so it's the same kind of stuff that we're talking about, is the product of the area of the base. So watch, it's the area of the base this time. It's not the perimeter of the base, it's the area of the base times. Now it says the perpendicular distance between the bases. That's a little wordy. I'm going to call it the height. Is that all right? So it's that looks very familiar, doesn't it? It kind of looks like lateral surface area, but lateral surface area was not area of the base. What was it? It was the perimeter of the base. This time, to find the volume, you find the area of the base and you multiply it by the height. So let's put that cylinder up here. Remember, I'll have to draw it real quick, but we'll put that cylinder up here and then talk about it and figure out how to find the volume. It's actually kind of easy. It's actually a little easier than finding the surface area, because you only got to do one thing. All you got to do is find the area of the base and then multiply it by the height. All right, kind of two things, but really, if you know the area of the base, you can just multiply it by the height and you got the volume. Simple as that. Let's draw a cylinder. All right, so here we go. We've got a right cylinder. Okay, it's straight up and down. It's a cylinder, and we want to find this time the volume, not just the surface area, but the volume of it. So let's put something in there. We can put it right here. Let's say that's, I don't know, let's make something up. Let's say 3. We had 3 before, didn't we? Let's say it's 5. Is that all right? So the radius is 5. What do you think the height is? 10? All right, we'll go 10. All right, so we'll say the height is 10. You with me? That's all you got to know in order to find the volume of the cylinder. So this is what you learn right here. You don't need a specific formula for this specific figure. This works with all kinds of different shapes. Okay, it doesn't have to be just a circle. So I'm not learning just one volume formula just for a circular cylinder. All right, I'm learning it for anything that's a pyramid. Well, let's say not pyramid, but yeah, what do they call it? Prism. Yeah, I always get that, for some reason I always get mixed up between the pyramid comes to a point, prism just goes straight up and down. Okay, so any prism or cylinder, this works for right here. I don't have to memorize a certain formula for every single different style that I do, and that's why I like doing this this way. So let's figure this out. The area of the base. It's not hard. What's the area? What's the base of this? It's a circle, isn't it? And how do you find the area of a circle? Pi r squared. So it's going to be 5 and squared. And we take that. That's pi r squared. That's the area of the base. You multiply it by the height. So what's the height? Well, what's the height? Height is just 10. Good. And now we can multiply it. This, and you're right, Judah. What is this? 25 pi times 10 is what? 250 pi. And if you want to keep it like that, oh, that's not area. What am I doing? You gotta stop me. This is what? Volume. Right, so volume equals, right, 250 pi, and that's it. If, let's say it was centimeters, what's volume measured in? Is it just plain centimeters? Is it centimeters squared? Right, what's squared? Squared is area. Cubed is volume. That's right. All right, you can just keep it like that if you want to. If you want to throw it in a calculator, if that really bugs you having that pi there, you want to chuck it in a calculator, times it by 3.14, feel free. I'll just leave it like that. Didn't even need a calculator, did I, for that, if you want to leave your answer like that. Pretty simple. And you can have crazy things too. You could have crazy different bases to this. Remember the one we just did with the rectangle and the half circle? You could do that one and find the area, or find the volume of it. And that wouldn't be hard at all. So what did we do? We found the area of the base and just multiply it by the height. Remember the problem we did earlier? I'm not going to put it up here because I have to redraw it again. But we already found the area of the base, right at the beginning. You just multiply that by whatever the height is, and bang, you're done. Volume. So volume's actually pretty easy, isn't it? Sometimes we think volume is harder than area, but you use area to find volume. But to find the volume of the cylinder, real simple. Find the area of the base multiplied by the height. Remember that. I put it in a box for a reason. Okay? Let's look, see what else we have here. Let's stick with volume, and let's do one more, and we'll quit after this. Okay? Then tomorrow we should be able to finish up tomorrow, I think. Let's talk about and this is the volume of a what? A cylinder. Or a what? What if the bottom isn't a circle? What if it's a different shape? What would we call that? Starts with a P. I get them mixed up. It's a prism, right? If it's the same on the top as it is on the bottom, it's called a prism. But what if it comes up to a point? If it comes to a point, we don't call it a cylinder, or we don't call it a prism. What do you think we call it? A pyramid. That's right. If it comes to a point, then we call it a pyramid. Or what if it's circular at the bottom? What do you think we call it? Now, cylinder's flat on the top. If it comes to a point, for instance, I've got this thing right here. It's a cone. That's right. This is a cone. Looks like an ice cream cone, right? Turn it up like this. Right? Ice cream. So this is a cone. Comes to a point. So it's not exactly the same. But if you have, here we go. Here's a pyramid, right? And here's a cone. You can't see this on YouTube, but who cares? So the basic formula is exactly the same. And this is actually kind of cool. Let me see if, is that the same height now? It'd be nice if I had one of these. It was the same height, but it's not. Let's see what this is. It's close. Now it's kind of chopped off right here. I got hungry, took a slice out of it. But let's pretend this came to a point right here, and it fit inside of this. Look, the bases are exactly the same, aren't they? Let's say it fit right inside of here. Let's say this was open, and I took this and I stuck it right inside of there. All right? Does it fill up the whole thing? Obviously not. There's a lot of gaps in there, isn't there? Okay? But it actually takes up the same. For everything that has the same base, this formula works for anything. That was a terrible explanation. But what it is, it's just, hold on just a second, don't leave yet. It's 1/3. So when we talk about a cone, okay, or a pyramid, watch this. The volume is equal to the area of the base, right, times the height, but it's 1/3 of that, so you just divide by 3. And that's the only thing different. Okay, that's on a cone or a pyramid. It takes up 1/3 of the volume of that cylinder. So watch, if I'd have a cylinder, if I'd have a cone, watch, it would come like this and like this. Do you see that? Do you see that cone right there? It takes up exactly 1/3 of that whole entire cylinder. All right, and that's what that formula is. Try to do some more problems tonight. We'll probably finish tomorrow, and then tomorrow I'm going to say have all the problems finished. Okay?